some will likely be toxic. I think that's the whole spectrum of nano. There's going to be some safe stuff. There's going to be some potentially dangerous stuff. If it's dangerous, why is it dangerous? And how can we make it safer? So these are some things to think about. These are the things I think about when I think about nanotubes. After exposure in the lung, where do nanoparticles and nanotubes deposit? What happens to them? Are they taken up by the first line of defense, macrophages? Are they cleared and thereby giving no disease outcome, resolution instead? Or do they persist if they're long, like asbestos fibers, and do they cause lung fibrosis? Or if we think of the macrophage as sort of as a catcher's mitt, where the nanoparticles evade the catcher's mitt and go somewhere else, where are they translocated to? Do they go to the mesothelium along the outer lining of the lung, the pleura? And do they cause DNA damage? And do they cause cancer like mesothelioma? We have no idea. I don't think we know. I'm sure we don't at this point, as a matter of fact. I think there's some evidence that we've already talked about that's very interesting, that's suggestive. Also, can nanotubes be taken up into the circulation and go to distant organs? Even before they get into the lung, when you inhale them, some things, some small metals, go up through the olfactory tract and go directly to the brain. Is that going to happen? We don't know. It may happen for some nanomaterials, maybe not others. So, in closing, I think it's important to consider a mouse-to-man translational approach that also includes in vitro cell culture models, in vivo models with exposure with rodents, and human exposures. There's epidemiology that's lacking here. We just don't have the epidemiology, which is a good thing because nobody is sick as far as we know yet. But we have an opportunity to perhaps get samples from occupational exposures at one point or the other. Look at dermal exposures, uptake into the brain, uptake into the lung, and translocation, as I've already told you. So with that, I should say the work that I showed you was done primarily by Jessica Ryman, who's now at the EPA in Washington, D.C., also Mark Sesta, who's a pathologist at NIEHS. This is Phil Bost, a graduate student of mine who's going to be working on some of this stuff. And also not shown is Lexi Taylor, who is doing an amazing amount of work in the lab too. Thank you.